10.4, graphing cubic functions. Cubic function, a little bit different than yesterday. We know that this here is linear because it has an exponent of 1. This here we talked about was quadratic, and it created a different graph. Here's linear, here's quadratic. Now we are going to have a cubic function. We're going to see what that cube does and how it affects and changes our graph. Looking at the first example, it says graph y equals x cubed. We know it'll change the graph. We're going to figure out how that changes the graph. So the way to do that is go ahead and make a table of values here. So I have y equals in for x is -2. There's that substitution, so I'm going to use a set of parentheses. Remember, when you substitute or you're taking something to some exponent in your calculator, you have to use the set of parentheses. So in your calculator, say parenthesis, -2, parenthesis, cube it, and then hit equals. If you do it by hand, we know it's -2 times -2 times -2. -2 times -2 is 4. 4 times a -2 is going to give us -8. So when we put in -2 here, we get -8. I'm going to go ahead and have you fill in the rest of the table, and we'll figure out the values there for y. There's what it looks like when my table's filled in. Go ahead and solve and find out the values. Here we get -1, 0, 1, and 8. Next, go ahead and write them as ordered pairs. So we have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Looking at the graph here, the x values are fine from -2 to 2. We can hit all those values, but we are not going to get from -8 to 8. So we need to change the intervals on our graph. I'm going to go ahead and go by 2's because I know I can get there going by 2's. So the y-axis will be going by -2's, and my x-axis will stay the same. It's going by 1, so I'll just leave that. Go ahead and plot -2, -8, -2, -8. Here's your plot. -1, -1, -1, -1. Here it is. 0, 0, 1, 1, and 2, 8. There's your plots. This is what a cubic function would look like. Okay, it does continue on forever, but it has a nice little swerve to it, increases and decreases, called a hyperbola. So this is what it would look like when you graph that. Notice this is when the x value, the coefficient, is positive. We're going to figure out in example 2 what happens when it's negative. So here's the negative look to it. Go ahead and we're going to fill in the table here. So we have y equals -x cubed. It's important to keep this negative sign right there. Now you're going to go ahead and substitute in -2. So -2, cube it. Hold that negative sign. Reason being is when you do this operation in your calculator or in your head where you get the -2 times -2 times -2, this is a +4. +4 times -2 gives us -8. Well, -8 is taking care of the stuff that's in blue there. We also have the negative sign out front. So a -8 is going to give us a +8 here. Again, let's go ahead and fill in the rest of the table. There's our table filled in. Take care of your exponent first. After you take care of your exponent, then you would go ahead and multiply by that -1 that you have on the outside out here. So go ahead and find your computation there for y. There's your values for y. Next, list them off as ordered pairs. Notice y values go from 8 to -8, so again I'll need to change my intervals here for y so I can get to 8 and -8. My x intervals can stay the same. Plot my points. We have -2, 8, -1, 1, 0, 0, 1, -1, and 2, -8. Look what happens to your graph in comparison to number 1. The only difference is the coefficient is negative here in 2. So basically what happened is this graph really just flipped over the y-axis. As we just mentioned, it says investigate the previous two cubic functions and equations. What happened and why do you suppose this occurred? Well, we've already mentioned why this occurred. As mentioned, the reason why the graphs flipped over that y-axis is because the x cubed value, the coefficient out in front of x cubed, was either positive or negative to create that flip. Next example says, in example 3, you'll graph the cubic function y equals x cubed plus 1. What do you think is going to happen when you add a positive number to x cubed? Then you'll need to test it and move on to the next slide. Remember yesterday when you had when this was x squared and you added 1. What happened? Well, your graph shifted up 1 unit. What happened when you subtracted here? Well, it shifted down. I'm guessing it's going to happen the same thing. So when you add that 1, the graph should slide up 1 unit. So I think that the graph will shift up a unit. First things first, use your substitution for that table. Go ahead and fill in all your values. So we have y equals, in for x here is -2. That's going to get cubed. We add 1. Fill in the rest of the table, then we'll figure out values for y. There's our values. Do our computation here. We get -7, 0, 1, 2, and 9. List them off as ordered pairs. Looking at our x values, the x values there go from -2 to 2. The y values here go from -7 to 9. So we need to make sure we're going to hit -7 to 9, so we'll need to change that axis. Maybe here I'll go by 2's again for that y-axis. Next, go ahead and plot the points. Remember, this is positive. Remember what the positive cubic function looks like. And then we are making a hypothesis here that when you add 1 that this graph should shift up. Here's what our plots look like. Here's what the cubic function looks like. Again, you can tell that in comparison to number 1, it did shift up 1 unit. And it is a positive, so it looks like that. This last little bit, I want you to go ahead and get used to using that graphing calculator that you'll see on your MCA. It's right at the top. It's also at the MCA prep down below, but we want to hit that interactive site. That calculator will pop up. Make sure we get into the graphing section so we can graph these lines and figure out the difference between them. So down here that gives you 4 examples, and the first couple examples you should actually probably be able to determine what's going to happen looking at your notes here. It gives us the 4 different graphs. We're going to compare to y equals x cubed. That is that first graph that you graphed. We're going to figure out what happens to each one of these graphs here. What happens when you add 2, subtract 2, when you multiply or the coefficient is 0.5, or when the coefficient is 2. We're going to see how that manipulates the graph. The first 2 questions you should be able to go ahead and answer right now. We've discussed that from example 3 and the previous unit. So I'll go ahead and type in the first 2 examples here, and then I'll have you use the calculator to try out the rest here. But we're going to start off with the original equation, and that is the x cubed feature. So that's where x is cubed. I'm going to go ahead and come up with that new graph. The second graph that we'll use, example 1, is x cubed plus 2. So we're going to figure out what is the difference between these 2 graphs. You're going to go ahead and hit graph, and that's going to tell us what is what. Notice x to the 3rd power is y1, or the first graph, and the y2 is x to the 3rd power plus 2. Hit graph, and we'll see the difference in the 2 graphs. We know that x cubed, looking at our notes, is this first graph right at the bottom. It goes through the origin. So that leaves us with the x2 here, or the x cubed plus 2, that it is increasing, or it shifted up 2 units. So I'm just pointing out here that the y1 graph is going through the origin, the y2 graph shifted up 2 units. So now we need to make that observation in our notes. The graph shifted up 2 units. Well, what do you think is going to happen in example 2? I'm going to guess it shifts down 2 units. Go back to your calculator. These values are still on the calculator, so how to get these off? You're going to hit the reset button in that lower right corner. It resets. Now you can go ahead and put in your information again. And an easy way to double check things is doing this. Plug in that first equation where you have x cubed, and you can go ahead and hit graph, and it shows you that that is the graph. Well, if you want to jump back, all you need to do is hit the expression component. When you hit the expression component, it comes back to this. Hit graph, it flips you back here. So when I hit expression and I'm comparing to this, I need to go ahead and say x cubed minus 2. So x cubed minus 2, and I go to that next page and I hit graph. You'll notice that the graph shifted down 2 spots from that original spot. So you could go back into the notes here and you make that comment. Once you go ahead and give example 3 and 4 a shot with that graph to see what happens by using that calculator. So there's that shift down. Check out example 3 and 4. Get in the habit of using that calculator that you'll see on the MCA test. Using your calculator, hit the expression button, come back. Really all you need to do is delete this expression. So I'll reset that the expressions here, and I'm going to say that, well, I want to use my x cubed and compare it to the next graph. Now maybe I'll graph just to look to see what x cubed looks like. Come back to the expression. I'm going to graph the next one, which is 0.5. So 0.5 x cubed graph. And if you look at the 2 graphs, I will let you know it's kind of difficult here being the same color. But what will happen is when you multiply your x cubed value by a decimal, so something that is less than 1, the curve is wider. Curve is wider. Reason why is it doesn't increase as much or as fast. Versus when you have something that is greater than 1, the curve will be narrower. Means that it will increase faster. So the curve becomes more narrow. This will conclude lesson 10-4, graphing cubic functions.